So this is tucked in another video, except I want to really bring it out to the focus. I am going to look at the three different types of chemical equations you can have. You have molecular equation. Well, another one is called the complete ionic. And last one is the net ionic equation, right? Now, to look at the way we're going to do this, I'm going to show an example. The first one I'm going to show you is if we have lead nitrate, PbNO3, and let's say it's lead 2 nitrate, plus sodium chloride, NaCl. And if you mix these two together, you're going to make PbCl2 plus NaNO3. Okay? This is going to be my way. There we go. So a couple of things that we know right now is that we're learning all about what's soluble or insoluble. This is going to be insoluble because it's lead. Lead, mercury, or silver mixed with chlorine is immediately going to be a solid. So the rules are, in order for you to have a chemical reaction, something's got to fall out of it. It could be a solid. In this case, we have lead chloride, it's a solid. It could be a liquid, which means it could be H2O. Or it could be a gas. And I'll give examples of each one. A gas would be, let's say, H2S. That's hydrogen sulfide gas. So let me run this one all the way through, and I'll show you two examples of the other ones. All right. So for this guy, if we put this is our molecular equation. This would be aqueous. This would be aqueous. This would be a solid, and this would be aqueous. All right. So looking at this, to make a complete ionic equation, I got to break this apart into its parts. So this would be Pb plus 2, aqueous, right? Plus the 2 comes to the front, 2NO3 minus, that would be aqueous, plus, and this is not balanced. Whoops, almost made a mistake. You have to balance these things too, and there would be a 2 in front of this. I would sit there and say this is 2Na plus aqueous plus 2Cl minus aqueous yields, this stays together, it's sticky, so it's PbCl2 solid plus, and once again, break them apart, 2Na plus aqueous plus 2NO3 minus aqueous. So now we just look and knock out our spectator ions. They do nothing. They just are on both sides of the equation. This guy, this guy, this guy, and this guy don't do anything. So that are my spectator ions. That is going to give me my net ionic equation, which is Pb plus 2 aqueous plus 2Cl minus aqueous yields PbCl2 as a solid. So that's how easy that one is, all right? I'm going to try another one, all right? Once again, following the same thing. I'm going to make water this time. So this is really simple. I take NaOH plus HCl yields NaCl plus H2O. I already told you, this is a liquid. It comes out. This is what's going to power the reaction. These guys will all be aqueous. That means they're diluted in water. So this is my molecular equation. Now I'm going to do my complete ionic. Complete ionic, I just break this apart. Na plus aqueous plus OH minus aqueous plus H plus aqueous plus Cl minus aqueous yields, remember, NaCl aqueous. Oh, whoop, sorry. Almost made a mistake. I'm kind of rushing here. Well, I want my eraser. Okay, whoops. NaCl is going to be aqueous. I got to break him apart. This is aqueous plus Cl minus aqueous plus H2O. Oh, I'll move you back. How do I get you out here? Oh. Whoa. All right. There is no undo. I have to use, come on, there we go. You won't let me use the, oh, there we go. This is embarrassing. Okay, good. Plus H2O, and this one is going to be a liquid. I got a different size, and that's going to bother me. Let's go back over here. So This is our setup. Now we just cross out our spectator ions. This is gone, this is gone, this is gone, and this is gone. So we end up with OH minus aqueous plus H plus aqueous yields H2O, which is a liquid. Yay, right? Nice. So let's go back over here. I don't want that so far away. I'm going to clear this thing, and I'm going to make this a little, I like it when it's a little bigger, and we'll make it 4. So we're going to do the last one, okay? Once more, we're going to make our molecular complete ionic net reaction. And for this one, I'm going to make a gas, right? So I'm going to say NH4 2S plus HCl yields, in this case it'd be, wow, you'd have NH4Cl plus H2S. I'm going to balance this and put a 2 in front of this guy, and I'll put a 2 in front of this guy, okay? So this would be soluble, it's aqueous. This is aqueous. This would be aqueous. And this is a gas. So this is what's going to power the reaction, right? I'm going to break this apart. So this would be 2NH4 plus S2 minus. Both these guys are aqueous. Aqueous plus 2H plus aqueous plus 2Cl minus aqueous. And keep in mind, the 2 transposes to both of these things. Then we have 2NH4 plus aqueous plus 2Cl minus aqueous plus H2S as a gas. It stays together, right? So you can see that sticks to the outside. Let's go ahead and cross out what stays the same. This stays the same. This stays the same. So now we got S2 minus aqueous plus 2H plus aqueous yields H2S. And once again, it is a gas. And that is my net ionic right here at the bottom. Okay, this seems pretty straightforward. That it does the same thing over and over for all these things. You just got to find out whether, and sometimes you'll get something that doesn't make anything. If you cross everything out, and say I'm going to get one where I'm going to cross everything out. So you can see that the last thing was, it's just weird when it happens, right? And we call that a no reaction. So if I grab something like, let's say NaCl plus NH4 NO3, right? These are both going to be aqueous. This will be aqueous and this will be aqueous. I mix this together, I get NaNO3, and the other one is NH4Cl. Now I'm going to look at this for a second. I'm going to say, wait a minute, that's 1A, that's a, this is all aqueous, right? This is real easy to do. All you got to do is put down no reaction, because nothing happened. All right, that's all.